Hello friends, today we analyze the lowest common multiple, that is LCM. Though this problem is related to elementary mathematics of class 5 in different standards or below the class 5 of different standard students. And basically they know about the positive integers and not know about the negative integers. So today we give a small introduction of lowest common multiple for both positive and negative numbers. Actually, we try to investigate that is the lowest common multiple is possible for negative number or not. So this is our prime motto to determine the LCM of negative number is possible or absolutely not. So for that purpose, we go through the basic definition of lowest common multiple. So the lowest common multiple of two numbers, suppose A and B, is denoted as LCM A comma B in under the first bracket, or is the smallest positive number M for which there exists positive integer in A and in B such that NA into A equals to NB into B equals to M. So in this definition, it is written as positive integers. Okay, so NA is the one positive integers A into A is the factor and NB into B, so that it will be equals to M. So from the above definition, it is clear that the LCM of number is positive quantity and it will be written as Na or Nb is greater than the, as I said, set of the positive integers, and M obviously greater than 0. So as per this definition, uh, A and B, the value A and B obviously they greater than 0. So there is no negative concept for LCM. So this is our general concept of LCM, that how LCM is determined by using the simple elementary method. Now we will see the universal method, actually the prime factorization method for finding LCM of numbers. So how the prime factorization method is under consideration, let's go through this example. The example of LCM 1230, we write down the prime factorization of 12 and 30 as below. The 12 is 2 to the power 2, that is 4 into 3, and the 5 into 0 is nothing but the 1. So 2, 3, 5. So these are the prime number. So 12 can be expressed as 2 to the power 4, 4 into 3, that is 12. Now for 30, the 30 is 2 to the power 1, 3 to the power 1, and 5 to the power 1. Why? The 2 to the power 1 is 2 plus the 2 into 3 into 5, that is 2 into 3 6 into 5 is 30. So to determine the LCM, we use the three prime numbers, mainly 2, 3 and 5. Now we write down the all three prime numbers leaving their exponents. So 2 is the first prime number, then 3 is the second, and the 5. And we will check that which one the highest value available in the factor 12 and 30. So in case of 12, the highest value between 2 to the 2 and 2 to the 1 is exponential of 2 to the 2 and 2 to the 1 is 2, then 3 is 1 and 5 is 1. So it is 60. Now you try to investigate using your traditional method, and you will see that it is correct, because the prime factors is 2 to the 4 into 3 into 5, that is the 60. So the LCM here, the 60. Now by using the universal method, that is the prime factorization method for finding LCM, is possible for minus 4 and 6? No. Why? Because using the prime number, you does not represent the minus 4, because if you try to represent it, then it goes to the imaginary number. Now the concept of imaginary number is different. But here, as per the definition, that set of positive integer, it is not possible. So we not take the prime factorization of minus 4. But if you consider the mod of minus 4, the mod is 5, we take the positive, so it is simple 4 and 6. So you not say that it is the LCM of minus 4 and 6. You have to say that it is the LCM of 4 and 6, because the universal prime factorization method not support the minus 4 and 6. So it is not possible to get the answer of LCM minus 4 and minus 4 6, or minus x comma y, or x comma minus y, or minus x comma minus y in this type of representations, because here the negative numbers in considers, and which is absolutely not possible to generate the prime factorization method. But if you consider the integer as minus 4 by minus 6, then what happens? The minus minus is cancelled out, and you minus 4 by minus 6, then minus minus cancel out, and you get the appropriate answer. So until and unless you take the mod of the negative numbers, you can't determine the LCM of them using the universal method to determine the LCM. So similarly, the least common multiple of more than two numbers is defined as the least common multiple of ABC. Okay, and it is like that the prime number of A1, prime number n e to the power n, where the a1, a2, an denotes the exponent of the prime of a. Similarly, uh, you have to represent like that p1, b1, pn, bn. So where the b1, b2, bn denotes the exponent of the prime of b and c. So the lowest common multiple LCM, so you can represent in this way, where the p1 is the first prime number and it is the maximum of these value a1, b1 and c1 like that. So which one is the maximum? P2. So in our previous case here the maximum value is to the 2 between 2 and 1. So similarly, we can determine the maximum value of U and AI and BI and CI like that. So here the PI are the all prime factors of A, B, C, and if PI denotes the occur in one factorization, then the corresponding exponent is taken as 0. So this is the example. Yes, you can determine the LCM of the factors. How? The half means the 2 to the power minus 1 and the 1 equals to 2 to the power 0. So the LCM of half comma 1 is the maximum. So the common prime is 2 and which one is the maximum power is 0, not minus 1, because 0 is greater than minus 1. So we take the 2 to the power 0, so that is the 1. So in this way we can determine the LCM. But the question is still there, that LCM of negative number is not possible using prime factorization method until and unless you take the mod of this number. Thank you.